This lesson is over Pythagorean theorem. And our Pythagorean theorem, we know we've been using it for a long time. We use it when we have right triangles. And so the theorem would say, if the triangle is a right triangle, then a squared plus b squared, or the sum of the squares of the sides, equals the hypotenuse squared. Okay, so you've got A and B are your legs, and C is your hypotenuse. So let's look at these and get some practice with Pythagorean theorem. So we have our hypotenuse is 13, so we would say x squared plus 5 squared is equal to 13 squared. Order of operations says that you should do your exponents before you do subtraction to get that x isolated. So we have 25 is equal to 169. Subtract 25 from both sides and you get that x squared is equal to 144. So I don't want to know what x squared is, I want to know what x is, and so I need to do the inverse operation, which is a square root, and then the square root of 144 is 12. So we find out that our missing side length is 12. So for number 2, we have our hypotenuse is 10. So we have x squared plus 5 squared is equal to 10 squared. So 10 squared is 100 minus 5 squared, which is 25, gives us x squared is equal to 75. And then you would take the square root of both sides. And so the square root of 75, it says to round to your nearest hundredth. The square root of 75 would be 8.66. 2 decimal places is your hundredths place, 8.66. You might be asked, particularly if you're in advance, you might be asked to leave your answer in simplified radical form. Remember, this is where you take your 75 and you go in and you split it. First thing that comes to mind that goes into 75 is 15. So, or excuse me, 5 times 15. And then 15 splits into 3 and 5. I have a pair of 5s, and so my 5 comes outside of the square root. I have a 3 left over, and so I leave it 5 root 3. So if you're asked to leave your answer in simplified radical form, then your answer would be 5 root 3. Otherwise, it's 8.66 rounded to the nearest 100th. Number three, even though this triangle is turned sideways, you find your 90-degree angle, and your hypotenuse is on your longest side. So now our hypotenuse is C, or is X. So what you want to be careful of, especially when you're doing this on the calculator will do the work for you, but be sure that you use parentheses. So we have 2 root 3 squared plus 2 squared is equal to x squared. And so when you type into root 3 squared, you're going to get 12 plus 2 squared, which is 4. And so you end up with 16 is equal to x squared. When you take the square root of both sides, you get that x is 4. So that's what it is. That's just a quick review of Pythagorean theorem. Now, one of the things that's new with Pythagorean theorem, maybe for you, is this idea of Pythagorean triples. Now, the Pythagorean triples, the benefit to them is they're just a quick shortcut. They are triangles that come out nice and pretty. If you've done a lot of Pythagorean theorem, you notice that you get a lot of decimals all the time. But there are certain ones that don't create decimal answers. They are triangles, right triangles, that have sides of 3, 4, and 5. You might have a set that has 5, 12, and 13. 8, 15, and 17 is another set. And the fourth set is 7, 24, 25. What that means is if you have 2 of those 3 sides, and you're given 2 of those 3 sides, if you have those numbers memorized, then you don't even have to do Pythagorean theorem. In fact, if you look back at number 1, I could have, if I had known those triples, notice that I have my 13. The hypotenuse has to be on your longest side. If anything is in the wrong place, then it doesn't work. It has to be your hypotenuse, the 5, 13, 17, or 25, those have to be on the hypotenuse, and the other 2 numbers, one of them has to be on the leg, one of the legs. So if I notice, I have 13 and I have 5. I could have not have done any of that work, and I could have just gone straight to 12, and 12 would have been my answer. So let's look at this. So I want the perimeter of ABC. So I want the perimeter of this triangle. I'm going to color it in to make it stand out. So I want the perimeter of this triangle right here. And so what I need to do is I want to find, I don't want to do the distance formula. I want to make use of Pythagorean theorem with all these grids. So if I look right here, if I want to find AB, I want to find this side length, this piece of the triangle right here. So if I want that, I notice that that side of the right triangle is 5, and this side of the right triangle is 12. Well, hey, I noticed that this is my right triangle and the legs are 5 and 12. That automatically tells me that my hypotenuse has to be 13. So it saved me some time. I didn't have to do Pythagorean theorem, and that's a good thing. Okay, then we come over here and we're going to find BC. So I want to find BC. So I'm going to draw in my, basically kind of my rise over run, my right triangle that forms it, because I can count my right triangles. I can't count my diagonals. The height is 3 and the width is 4. And I know my triples. And so if I have a 3 and a 4, that means that my hypotenuse has to be 5. If I have 3 and 4 on the legs. So then we have C. C is my last one. So I want AC right here. Okay, so I'm going to draw in the right triangle that's there. It's not the only way to draw in the right triangle, but I try to draw on the outside of the yellow triangle and not the inside to make it cleaner. This is 2. And this is 16 as I count it, and there's not any triples. There are no magic numbers, 4, 2, and 16. So on that one, I actually have to do Pythagorean theorem. So 2 squared plus 16 squared is equal to C squared, my hypotenuse squared. Well, 2 squared plus 16 squared is 260. And then I want to take the square root of both sides to clear out that square. So I'm left with C is equal to 16.1. We'll just round to the nearest tenth. And I asked for that, finds that green side, but I asked for the perimeter of the triangle, which is the sum of all the sides. So I would take 16.1, and I would add 13, and I would add 5, and that gives me 34.1 is the perimeter of that triangle. But the benefit of the good thing is, while it was asking for you to do Pythagorean theorem 3 times, we didn't actually have to because we knew that shortcut. And again, if you don't remember the triples, it's okay. Then just do the Pythagorean theorem and you'll get the same answers. Now, we can do all of that with, if the triangle is a right triangle, then you can use a squared plus b squared equals c squared. So we want to use the converse, the if q then p. So it says if a squared plus b squared equals c squared, or, right, if we have it right here, a squared plus b squared equals c squared. I'll explain in a minute why I have them written backwards. Then the triangle is a right triangle. So if it's a right triangle, we can use the Pythagorean theorem. If I use the Pythagorean theorem and it is equal, then it is right. Now, what if it's not equal? If it's not equal, it can be greater than or it can be less than. So here's the important part, what I want you to know. If c squared, if the hypotenuse squared is greater, okay? If c squared is greater, then the triangle is obtuse. And I write it this way instead of saying a squared plus b squared is less than c squared like that, because then it's less than c squared, but that doesn't make sense because to me, greater than, even though these two statements are exactly the same. I just wrote them in a different order, but they're exactly the same. Notice the symbol is pointing towards in the same direction. It's pointing towards a squared plus b squared, which means a squared plus b squared is less. But I think that thinking about obtuse and greater goes together, and thinking about if c squared is less than, right? If c squared is less than, it goes with acute, because acute angles are less than 90, obtuse angles are greater than 90, and so it's always easier to base it off of what happens with c squared. Now, in order to do these problems, you have to decide first, is it a triangle? All of these are drawn, they're not drawn to scale. So you cannot assume that they're going to make a triangle by looking at it. We need to test it. So the first thing, remember that when we test to see if it's a triangle, the main focus is that your two short sides, the sum of your two short sides has to be longer than your third side. So my two short sides are 5 and 7. My long side is 11. And 5 plus 7 is greater than 11. So the first question is it a triangle? That's the first question. Okay, so 5 plus 7 is 12, which is indeed greater than 11. So yes, it's a triangle, which means I can keep going. Now, what kind of triangle is it? So this is where we're going to test it. So if we go up here and we go, okay, C. Well, C would be my hypotenuse, which would be my longest side. So 11 is my longest side, so I'm going to do 11 squared. So first I'm going to do C squared. That's 11 squared. And then I'm going to test it against A squared and B squared. So my other two are A squared plus B squared. It doesn't matter which one's which. You could switch them and do 7 squared plus 5 squared. It doesn't matter. So 11 squared is 121. And 5 squared plus 7 squared is 74. And so the question is then, is C squared equal? Is it greater than or is it less than? Well, C squared is 121. And it is indeed greater than 74. C squared is greater than, so C squared is greater. I'm just going to put that over there so we have a note as to why this is the answer, which means that this triangle would be obtuse. Now, you could go into GeoGebra and draw these triangles and make them match up and draw it to scale, and it would actually be an obtuse triangle. Okay, so on this next one, we don't know how long 4 root 3 is, so that's okay. We need to know which one is our longest side, so let's do a quick check. So type in 4 root 3 on your calculator, and you'll get 6.9. Okay, so we need to check, is it a triangle in the first place? So if we test 4 plus 6.9, that is greater than 8, so yes, it's a triangle, which means I can keep going. So once I know that it's a triangle, we have to decide which is my longest side. Well, that means 8. 8's my longest side. So I would do 8 squared, and then I would do 4 squared plus 4 root 3 squared. Be careful, 4 root 3 squared in parentheses. So 8 squared is 64, and 4 squared plus 4 root 3 squared, all in parentheses, is also 64. And so you look and you say, okay, what is C squared? Well, C squared is equal. Remember, this is C squared, this is A squared and B squared. So C squared is equal. So since C squared is equal, that means this is a right triangle. And if I were to draw it to scale, like on GeoGebra or on a piece of paper, I would end up seeing a right triangle. Okay. So number 7. On number 7, we need to test it and make sure it's a triangle. My two short sides are 5 and 7, which is greater than 8. So yes, it's a triangle. So that means I can determine what kind of triangle it is. See, y'all, if it isn't a triangle, then it can't be a right triangle. If it isn't a triangle, it can't be obtuse, or it can't be acute. It can't be some kind of specific triangle if it's not a triangle at all. And so now I test it. So my hypotenuse would be 8. My longest side is my C. So 8 squared, and then I compare that to 5 squared and 7 squared. Well, we did 5 squared and 7 squared a minute ago. That was 74. And 8 squared is 64. Remember, this is my C squared. So C squared is less. So since C squared is less, that means that this triangle is acute. And then number 8. Number 8, first I got to check, make sure that it's a triangle. So I check, my long side is 7. So I check 3 plus 4, and I check to see, is that greater than 7? That's not true. It's not a triangle. And so you would just say, not a triangle, and you're done. Now, here's the tricky part. If you forget that you were supposed to check to see if it was a triangle first, there's not a way to tell whether it'll work. it'll show you and it'll make you think it's obtuse. So look, don't write this, but if you do 7 squared and then you do 3 squared and 4 squared, you'll get that 49 is bigger than 25, and you'll think, oh, it's obtuse because c squared is bigger. But it wasn't a triangle in the first place. So this right here says stop. You can't go any further. It's not a triangle. So it is not obtuse. So you don't want to do that. You always have to check and make sure that it's a triangle first. Now remember, when do we use this? We use this when I need an angle name, but I only have sides to give. Earlier in this unit, I gave you sides and I gave you angles and you could classify it. But this time I'm able to give it an angle name, acute, right, or obtuse, but that is based off of the sides. But we do have to check and make sure that it's a triangle first.